Today we are solving equations using multiplication and division. Now remember, an equation means that this side of the equal sign equals this side of the equal sign, and we always have to keep that balanced. So once again, when we are solving with multiplication and division, the key concept is inverse operations. So let's start with the multiplication problem. When I say multiplication, where I have my variable, notice it's some number divided by 4. Well, the inverse operation of division is multiplication. And I always start on that side that has that variable, and I need to get the variable by itself. So I have to get rid of this divided by 4. Well, how do I get rid of it? Well, that inverse operation, which is multiply by 4. But the moment I multiply this side by 4, I went out of balance. And in order to pull myself back into balance, because I have to remain in balance, I have to do the same thing to the other side, which means I'm going to multiply by 4 on that side. Now, when I do this, these cancel out, because by definition, those inverse operations cancel those numbers out, and we're left just with our variable. Now, 6 times 4 is 24, and I know that's correct because when I plug in 24 for that variable and I divide it by 4, I see 6 equals 6, and I always do my check just to make sure that my answer is correct. Now, division works the same way. You're going to start off with a problem that looks like a multiplication problem. So this is 5 times C, because remember, we don't use the multiplication symbol. And so I need to get C by itself, but it has this times 5. How do I get rid of times 5? Well, I divide by 5. But if I do it on that side, I went out of balance. I have to do it on the other side to pull myself back into balance. So whatever you do to one side, you have to do to the other side. Now, I know a negative divided by a positive is a negative, so I still have to follow my rules of integers. These cancel out because they're inverse operations. So my answer is C equals -3. Again, I'm going to plug it in to see if it works. 5 times -3 is 15. I'm sorry, 5 times -3 is -15, and that equals -15. I know that is a correct solution. So sometimes though we're going to have to gather some like terms. In this example, I'm gathering my like variables together. You can't begin solving unless you have all your variables in one pile. So when I look at this, I see I have 12y and 10y. Well, I need to just put those together as 22y before I begin to solve the problem. So really my problem is -110 equals 22y. Now it's kind of easy because I need to get y by itself, but it says times 22. How do I get rid of times 22? Divide by 22. But whatever I do on one side, I have to do on the other. That's the key concept here. And when I divide -110 by 22, I get y equals -5. Once again, I plug it in to make sure both sides remain equal, because that's the concept. If it's an equation, they both have to remain equal. Sometimes though, I'm going to have to gather my constants. So you might be gathering your variables or you're gathering your constants. Whenever there's a like term, you got to pull it together. So when I see 9 minus -4, I change that minus to plus the opposite. So I really can see that's 13 for that. So it's some number, which we're saying is W, divided by 8 equals 13. Well, I need to get W by itself, so I need to get rid of this divided by 8. The way I do that is the inverse operation, which means I'm going to multiply by 8, but I'm out of balance unless I do the same thing to the other side. So when I do that, these cancel out, and I'm left with 13 times 8 is 104, and if I plug it in, I can see both sides equal 13. So solving equations algebraically, it's not difficult. It's always using inverse operations, and whatever you do to one side, you do to the other. We are ready to move on to some more complicated equations. Let's practice this today to make sure you have it down. Good luck.